All right, year 10s. Let's get going. Okay, I've put a whole bunch of information on the board. I'm not expecting you to write all of this down. I'm just going to highlight the key bits of information that you might want to pop down into your notes. Okay, probably way back in year 7 or year 8, I don't remember exactly when it's covered, you would have learnt, or maybe even like in primary school, you would have learnt the old 2 is less than 3. Remember doing that one? Yeah. Remember the crocodile eating the bigger number or whatever they say to you at the time? Okay. Remember as well, you might have had something like x, an unknown, is less than 3. It might have been it was less than or equal to 3. Remember that little sign being thrown on there as well? No. Okay, so to give you a really brief rundown on it, and we'll deal with unknowns for this one because that's what we need to work with today. We could have something like x is less than 3. So that sign there is for less than. So write that down if you don't remember. The squiggly one. That's less than or equal to. That squiggly one.
Oh no, those like the one that looks like equals.
Do you mean that one?
Yeah.
That's approximately equal to. And there's triple equals, which is congruent, I'm pretty sure. I get confused between, oh no, that's congruent, and then that one is similar. Yeah. Okay, so that's less than or equal to. And then in the other direction, we could have greater than. So that could be, I'll just do x and 3 again. Or again, if you have the greater than with the little extra line on there as well, that's greater than or equal to. So in this case, it means that x could be 3, but it could be bigger than 3 as well. Whereas this one here means it's bigger than 3, but it doesn't include 3 as well. So greater than or equal to. Okay, so the last time you would have worked with this, again, it's just deciding which inequality belongs, whether something's less than or equal to or whatever. In this course, in year 10, we need to take this information and put it onto a graph. That's skill number 1. That's what we called writing and graphing as an inequality. So writing it as an inequality, drawing the graph is graphing it. But we're also given problems like these ones here, where we have to say, well, x is going to be greater than something, but we have to treat it in a similar way to solving equations and figure out what that something actually is. So what we'll do, we'll start off with the first part, which is the writing the inequalities down. So in this one, we're dealing with a unknown. It's written in a graph that's pretty similar to this. But in these examples on the board just here, it gives you a little rundown as to what these two symbols mean. So if you've got a number line like this, let's say it goes from -2, -1, 0, 1, and 2. If you wanted to write down, well, I've got a value of x, an unknown value, and I know that that's going to be a number that's bigger than, let's say, -1, but not including -1. The way that you would write that down on the actual graph like this is to start off at -1 here, draw a little circle that's not filled in, and draw an arrow going this way like that. So that's the graphical version, or the graph version, of what we've written here as our inequality. It tells you that this value x, which could be any number that's bigger than 1, shows you here that's the smallest it can be, or well, really it's not the smallest it can be, it's the one slightly before the smallest it can be. It can be anything greater than that. If we changed it to graph x is greater than or equal to -1, the way that we write it on here is a little bit different. That dot, instead of it being a not filled in circle, that becomes a filled in circle, like that. So now this graph shows us x is greater than or equal to -1. So that's important to remember. If you've got the circle filled in, it means included. If you've got the circle not filled in, it means it's not included. So not filled in, don't include it. Filled in, include it. Now that also works if you've got a range of values as well. So I'll just rub that out real quick and say, what if we know that x is greater than -2, but we also know it's less than or equal to +1. Sometimes you'll have to graph a range of values like that. The way that you do that is to have a circle filled in here, because it's less than or equal to 1. And it's greater than but not equal to 2. So I'll do the non-filled in version, and I'll draw a line between them like that. So that inequality there, so an unknown value that we know is bigger than -2 but less than or equal to 1. That's how we would write that down. All good so far? Pretty much? Okay, I'll carry on for now and then we'll see how we go. So that brings us to the 3 or 4 examples that we're going to do. So the first one is to write these as an inequality. It means that we've got a inequality in graph form, but we need to write that down in this x is greater than or equal to whatever. Okay, so here we've got some value along here. We know that it's greater than 2, because that's the area that's filled in on the graph. So we could write in for that, x is greater than 2. And that's it. That's all you have to do. Even though we don't know what that x value is, we know that it's bigger than 2, whatever it happens to be, or whether it's, it can't be anything less than 2 or whatever. So that's how you write that one down. The one that's on the right-hand side just here, we know that it's greater than or equal to -3. Hi. Oh, I've put it on connecting the plexiglass. Yeah, cool. And I'm filming it as well, and I'll upload it so you can watch that as well. Cool. So it's greater than or equal to -3. So I put my and equal to there as well. And I know that it's less than 0, but it's not equal to 0. So I'm going to write it down like that. And that's it, done. So when you see the question write as an inequality, take the information from the graph and write it in this form here. Cool. Right, that brings us on to the solving and graphing side of things. There's a bit more information on the board about this. The biggest thing that I'll point out to you is that we can solve these in the same way that we solve regular equations. The big difference is if you multiply or divide by a negative number, you have to reverse the inequality sign. The reason for that is if you had, let's say we had a number line here. I'll just sketch this super fast. If we had 1 and -1, let's say that that's, -1 like that. At the moment, we know that 1 is greater than -1. But if we multiplied each of those by a negative number, let's say we multiplied them by -2 or something, this would become -2. This would become +2 because it's a negative times a negative. So now we've reversed the direction of what's the biggest out of the two. So I'd have to reverse the sign as well. So that component's really important. If while you're simplifying you multiply or divide by a negative number, make sure you reverse the sign on there. Okay, so now we're ready to give a couple of these a try. There's got to be a more efficient way of doing that. Okay, so we're going to start with that one on the right-hand side. For each of these, we need to solve them and graph them as well. Okay, so starting off with this one, again, we're going to treat it as a regular solving problem with the normal rules that apply to begin with. So 3x plus 4 is greater than 13. I'll take away 4 from both sides. 3x is greater than 9. And it's already looking pretty straightforward. So 3x divided by 3, 9 divided by 3 will give us x is greater, I can do a better greater than for that one for sure. X is greater than 3. So that's part 1. So I've got my value for x, I know it's greater than 3, but I need to graph it as well. So you can draw yourself like a nice little scale like that. I'm going to go 0, 1, actually no I'm not, I'm probably just going to start off on 3 to be honest. Let's go 3, 4, 5, that would probably do it. It's greater than 3, so I'm going to do the not included version. It's greater than 3 like that. So if we've not got that range of values like we did with that other problem before, we just put that little arrow on there to say it's going to go in that direction potentially forever. There's no upper limit on it. We just know that the number is greater than 3. Cool. That brings us on to the second one. So 4 take away x over 6 is greater than or equal to 6. So we'll start off for this one by taking 4 away from both sides. So we've got negative x over 6. And I've taken 4 away from both sides, which is why that's disappeared. 6 take away 4 is 2. Okay, so now to get rid of the x over, or negative x over 6, what I'm going to have to do to this one is multiply it by 6 to get it on this side as well. You could do that a couple of ways. You could either multiply it by 6 and then multiply by negative 1. I'm just going to multiply by negative 6, so I do it in one step. That's going to give me positive x over here. On this side, I've multiplied by negative 6 to give me negative 12, because it's 2 times negative 6. But because I've multiplied by a negative number, I now need to change the direction of the sign. So now instead of it being less than or equal to 2, I'm going to go greater than or equal to negative 12. So it's really important that you remember to switch it over if you multiply by a negative number. Now I'm going to graph it as well. So let's say I've got negative, greater than. We'll start here, we'll go negative 12, negative 11, negative 10 will probably do. It's greater than or equal to negative 12, so I'm going to say it's included and draw my little arrow like that. Good one. Okay, now we've got the last bit of the puzzle to do. So now we've got an example where we've got the unknown on both sides of the inequality sign. But again, we just treat it like a normal solving equations problem. So I'm going to take 3x away from both sides. That's going to leave me with nothing over here and 3x on this side. I'm going to get rid of the negative 4 on this side by adding 4 to both sides. So it'll give me nothing over here and positive 6 there. So know that's, I don't need to write positive, sorry. So now I know that 6 is equal to 3x. I'll divide both sides by 3. 2 is greater than x. And the way that I'll actually leave that as my final answer, sorry, I keep drawing these like 7s today. I must have 7 minutes on the brain or something like that. So I know that 2 is greater than x, but that's technically right, but you know that with most of these sorts of problems, like if we'd solve equations, we normally leave it with x equals whatever. So I'm going to do the same thing for this one. I'm just going to switch the direction here. So rather than 2 being greater than x, I'm going to write it as x is less than 2. So I've got my x on the left-hand side. And then to graph it, I'll say, I've sort of run out of room a little bit here, but I'll say I've got 2, 3, and 4. It's greater than 2, but not equal to it. So I'm going to use my not filled in circle and draw my little arrow there like that. Okay.
Why does x equal 1 time?
Oh, did I make a mistake somewhere? Where did I make a mistake?
What is that? What is that? Since x is less than 2, it needs to be
Oh, yes, sorry. It was a test and you passed. Good job.
So what is that?
Oh, it's whatever, but I did it in a very offhand sort of way. It was just to say that when we write our answer, x is equal to whatever it happens to be. So we've changed it from 2 is greater than x to x is greater than 2. So we just put it that way around. Okay, thank you for picking me up on that. That's very helpful. All right. Okay, so my answer there is going to be I'm not including it. So I'll pop that there. And my arrow is going to go in that direction instead. Okay, lovely. That pretty much brings us on to the questions.